All right, let's continue on right here in 5.2, properties of rational exponents and radicals. And we're going to look at these four problems, writing the expressions in simplest form, assuming variables are positive. Now, a little side note, I guess, right here. It's important to assume that variables are positive, especially when we're working with exponents. The reason being, and this is a little extra side note that you could add in. We'll actually talk about a lot more of this later on in the school year. Is think about this right here. If I take the square root of x squared, okay, hopefully you realize that that the square root of x squared, it will be x. Now, is that a true statement? Think about plugging in some numbers. So if I plug in 1 for x, 1 squared is 1, the square root of 1 is equal to 1. Okay, so that works out. The problem here is this. What if I plug in negative 1 right here? So what we're saying is if f is equal to negative 1, does that equal negative 1? Well, 1 squared is 1, the square root of 1 is 1. Well, what I see right here is that those two are not equal to each other. So the key here is this. When I have right here a variable with an even exponent and it turns odd, see, because take a look, it went from even to odd. I have to put the absolute value around the x in order for it to be true. Because in this instance right here, if I said that x is equal to negative 1, and when I plug in negative 1 right here, it's not equal. So therefore the absolute value is necessary. So that's why they talk about assume all variables are positive, because we'll worry about that a little bit later on. But that's just a little extra tidbit to add to your knowledge bank there. So let's start with number 13. Okay, so we have right here negative 2 cube root of 5 plus 40 cube root of 5. So the important thing right here is that the indexes are the same. We also have right here that all of this is the same. So it's like saying they have the same variable. So I could add or subtract both of these together. So then I want to go ahead and look at the negative 2 and the 40 and add them up, and that becomes right here 38. We got 38 cube root of 5. We went ahead and simplified that. I can't take the cube root of 5. I can't do anything with that. So that is it. All right, next up, let's take a look at 14. They got some big numbers there. We got to work and try splitting things up. I say it's probably easier for us to take a look at this 32 and try to find, well, what are numbers that I could take the fourth root of that have a factor of 32 in it? If you try 4, the fourth root of 4, I can't do that. So let's try some other numbers. How about this? How about if I take 16 and 2? Okay. I could take 16 and 2, that equals 32. The fourth root of 16 right there happens to be equal to 2. All right, so knowing that, so I guess a tip right here that I'm trying to share is, well, let's take a look at the smaller numbers and see what I could take the fourth root of. All right, so the fourth root of 16 right there ends up being 2, and I'm left with 2 to the 1/4 power. So how is that going to help me? Okay, well, let's take a look at 1,250. If we're going to be able to subtract these, the base has to be the same. So it looks like the base right here has to be 2. Well, that helps me out. That narrows things down for me, because let's take 1,250 and divide it by 2. That ends up being right there 625 times 2 to the 1/4 power. Well, let's see right here. 625, can I take the 4th root of that? It looks like I can, and that right there will get me 5. So I'll have 2 times 5, and then I'm left with 2 to the 1/4 power. And guess what? It looks like these two terms are exactly the same, because 2 times 5 is 10, so I got 10 times 2 to the 1/4 power minus 10 times 2 to the 1/4 power, and all this combined, that equals 0. All right, so we now simplify it. Something that looks really large, possibly daunting, but if you kind of try to use some sense and think, all right, what are some 4th roots? You're going to have to probably use your calculator right here to kind of help you narrow that down. Then you're able to find your answer. Let's take a look up next at number 15. We could split things apart since we're dividing. We can combine things together because we're multiplying. Some problems, it might be easier to do one over the other. A lot of it's just going to come down to experience. What I see here is this. I could take the 4th root of 16. We're starting to look at some of these numbers over and over. I could take the 4th root of 36. Remember, the rule here is this. If I have an exponent and I have right here the 4th root, you're actually dividing it by 4. Because let me show you right here. What exactly am I talking about? It says, you're crazy, Mr. Kim. Well, not really, because remember, our rules here is this. If I were to rewrite this using exponential form, it would be the 4th root of all of this is the same thing as raising it to the 1/4 power. And when I raise a power to a power right here, you're going to divide. That's why, if you haven't noticed, whenever we took the square root of like x to the 4th or x to the 10th, we always divided the powers by 2 because 2 was the index. Works out, right? So let's go ahead right here. I'm going to simplify this down right over here because let's see. The 4, if I take 16 to the 1/4 power, that is actually going to be 2. And then I take x to the 36th power, raise that to the 1/4. That'll be x to the 9th. All right. So now, normally I would say, all right, we need to put absolute value there. But if you remember what we talked about in the beginning of the lesson, but because we say assume all variables are positive, we don't have to worry about that. We'll leave it as is. But that's why I mentioned what I did earlier. Up at the top right here in the numerator, well, the radical is the same. So let's go ahead and combine things together. And I've got right here the 4th root of 81 x squared. And so from here, let's see what we could simplify. All right, there's got to be more. It might be easier right here for us to take this 4th root right here of 81x squared and raise that to the 1/4 power. Let's see if I could take the 4th root of 81. There might be ways for us to simplify some of these things, some of the numbers here. Let's see, what can we do? What can we do? How about, I can't divide 81 by 2. Maybe if I take 81 right here, divided by 3, that gets me 27. Or, let's see here, looks like if I take this and I change that to 3 to the 4th power, then I can go ahead and multiply that by 1/4. And guess what? I'm just left with 3. So let's go ahead. I want to rewrite this 81 as 3 to the 4th. And then let's go ahead and raise our power to a power right here. And so 4 times 1/4 is going to be 1. So we got 3 right here. And now I'm left with is x to the 1/2 power, because it's going to be 2 over 4. So we got ourselves 3 times to the 1/2 power. All right. How does that look? Hopefully good. And then let's go ahead down below. We've got ourselves 2x to the 9th. So if I were to maybe simplify it in radical form, it would be 3. And then I'm now left with the square root of x over 2x to the 9th. And there you go. There's number 15. Let's take a look at the last problem right here with number 16. And once again, there's a lot going on. I think right here on this problem, we're going to be using the quotient rules. And we don't want negative exponents, so we might need to move things around. So let's see what I could do. I want to start off right here and take a look at this 7 to the negative 1st power. It doesn't really help me too much there. So let me move that to the top. So I have 21, and I want to go ahead and multiply that by, or right here, plug up 7 to the now 1st power. Okay, so we've got that. Next up, let's see what else I could do. I now have, let's see, we take a look at our x's. Remember, this right here is actually x to the 1/2 power. And if I'm going to be subtracting right here, because I'm dividing, right, I want to go ahead and let's highlight right here what I'm looking at exactly. It is the x's. Let's go ahead and rewrite this as x to the negative 3/2. And then it's going to be plus, or sorry, since we're subtracting, it'll be minus 1/2. So there's the x. Let's take a look at the y right here. I've got the square root of y. Let's rewrite that as y to the 1/2 power. And then we're going to subtract right here a negative 1/2, because that's what our denominator is. All right. And then finally, for the last part, for z, I might need to move it down here. It'll be z, and then we have 5/2 minus 1, because z has an exponent of 1 right there. So let's start simplifying all of this together. We got 21 times 7. I've got 147 right here. Negative 3 minus, or 3/2 minus 1/2. Luckily we have common denominators, and then that looks like it's going to be negative 4 over 2. So negative 4 over 2, or that will become negative 2 right there when we simplify that. For the y's, I've got 1/2 minus negative 1/2. That'll give us y to the 1st power. And then we have 5/2 right here. We're going to subtract 1. We get common denominators. This will become 2 over 2. So 5 minus 2 is 3. And then we have ourselves 3/2. All right. So we've got all that down. And let's see what else we could do right here to simplify this. Remember, we do not want negative exponents. Okay. Yeah, so no negative exponents. So let's go ahead as I rewrite this. I've got 147 will stay on top. This x squared will bring down below. The y will stay on top right there. And then I've got, finally, we've got z to the 3/2 power. And there you go. We have simplified it. We might be able to simplify it a little bit further. If I were to actually, as a side note right here, to think that this problem is already done or doesn't have any more stuff to it, there actually is. Looks like I could rewrite that as square root of 2z to the third. And I could actually split this up. Now, I can't take the square root of an odd exponent. So this is actually a good little extra bonus right here that you guys are getting. And the bonus here is this. I can split this up right here. Because I can't take the square root of a negative exponent, what I can do is take the square root of, an odd exponent, is I can split it apart like so, right there. I could take the square root of z squared. So this is important right here to know that I can't take the square root once again of an odd power, but I could take the square root of an even power. And so what I can do is split this apart so that it becomes part of it is even, and then we have part that's odd. We're only going to reduce it down by one power. So if I had right here like the square root of z to the 49th power, what I would do is split it apart where it becomes z to the 48 times z right there, because these are both the same thing. And then I could take the square root of z to the 48 by dividing it by 2, and this would be simplified down to z to the 24th rad z. So this right here is actually going to be z times rad z. So it actually worked out. I got to show you another cool little trick here. And so we have 147 y, and then this will now become z rad z all over x squared. And now we are done. All right, so we kind of put all the tricks together right here in 5.2, all the different properties. It's going to once again take a little bit of effort on your end, kind of recalling, thinking, trying to find numbers that work, that you could take the radical of, and I'm sure you're going to be able to, you'll be just fine as you guys keep practicing and working on this. All right, there's 5.2.